In this video, we're going to talk about how to graph square root functions and describe key features. So the square root parent function is given by the equation f of x equals the square root of x, and you can use a table of values or Desmos to graph the square root parent function. So if I'm graphing square root functions in Desmos, I can type sqrt to get the square root symbol, or I can go down to the keypad and I can choose the square root sign. So I'm going to graph the square root of x, and I want to fill in this table of values. Well, Desmos will give me a table of values if I click on Edit List, and then I choose this table button right here. So notice this is asking me for specific values of x, and so what I'm going to do is I'm going to replace the values that Desmos already has in there with the ones that I'm looking for. So that's going to help me fill in this chart, and I don't need this last value, so I'm just going to go ahead and delete that. So now I can use this to fill in my table. So I have 0, 0, 1, 1, 4, 2, and 9, 3. So I'm going to go ahead and plot these points on my grid, and I'm going to use that to recreate the graph of the square root function I see in Desmos. So once I connect these points, I can get an idea of the shape by looking at Desmos. And notice that this graph does go on forever to the right, so I'm going to put my arrow at the right endpoint. So when we look at square root functions, we want to look at these key characteristics: the domain and range, the intercepts, and whether the graph has maximum or minimum values. So the domain and range, remember, the domain is all possible x values of a function, and the range is all possible y values of a function. So let's practice by describing the domain and range of this square root parent function. So notice the x values have a specific starting point. They start off at 0 and then they continue forever to the right. So we would say the domain is going to be square bracket at 0 because that's the starting point, and then it goes all the way to the right to positive infinity. The range also has a starting point because it starts off, the lowest y value I can see here is 0, and then from there my graph is going up. So I would say the range goes from 0 to positive infinity. So think about this. Notice that all real numbers are not included in the domain of a square root function. So why do you think this is true? Let's look at the parent function f of x equals the square root of x and think about what x values are not included in the domain. So we already said the x values start off at 0 and then go to the right. So this means that negative values like -5 are not included in my graph. Because notice when I type -5 in the table, it says the function is undefined. So why is the function undefined? If I plug in -5 for x, notice that I get the square root of -5. And remember, back in last semester, we learned that this is equal to I times the square root of 5. So our graph, our coordinate system, only graphs real numbers. So we don't graph imaginary numbers on our coordinate plane. So that's why this function will be undefined at -5. Okay, so that's why square root functions can only include positive values of x, because we're not going to be able to take the square root of a negative number and get a real number as a result. So now let's think about the intercepts. Remember, the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So this square root parent function actually has this point right here, 0, 0. And so that's going to be both the x-intercept and the y-intercept. Because remember, the x-intercept occurs where the y value is 0, and the y-intercept occurs where the x value is equal to 0. So remember, the minimum value of a function will occur at a point that has a y-coordinate that's smaller than all the other points on the function. The maximum value of a function will occur at a y-coordinate that is larger than all the other points on the function. So if we look at this graph of the square root parent function, notice that this y equals 0 is going to be the lowest y value. Every other y value on this function is going to be higher than that. So we would say it has a minimum of 0, and that occurs at x equals 0, because that's going to be the lowest point on our function. So now let's practice with some different square root functions. Let's graph f of x equals the square root of x plus 4 minus 3 and describe its key characteristics. So I'm going to go ahead and type this function into Desmos. So I have x plus 4, and then I have to click outside of the square root to put that minus 3 on the outside. You want to be very careful in doing that, because if you just keep typing, it puts everything under the square root. So now let's look at some key characteristics. So I'm going to click this edit list and then create the table. I'm going to type in the values we need, which are -4, -3, 0, and 5. And I don't need this last value. So I'm going to use that to fill in my table. So now I have an idea of some points that are included on the graph of my function. So let's describe the domain. Well, notice the domain, the lowest x value I can see here is at -4, right? Because every other value is going to be to the right of that. So it's going to go from -4 to positive infinity. The range, the lowest y value is going to be -3, and then every other y value is going to be above that. So it's going to go to positive infinity. Now let's think about intercepts. Well, the x-intercept is going to be at 5, 0. I can just click on that to find the coordinates. So we have an x-intercept at 5, 0. The y-intercept will be where the graph crosses the y-axis. If I click on that, it tells me it has the coordinates 0, -1. You can see based on the shape of this graph that that starting point right there at -4, 3, and -4, -3 is going to be a minimum. So that means we have a minimum of -3 because that's the lowest y value, and that occurs at x equals -4. So now you can go ahead and pause the video and try doing this example on your own. So you can see here, this graph has the following points that I can use when I create this table of values in Desmos. And then it has a domain that starts off at -5 and then heads to positive infinity. The range starts off at -4 and heads to positive infinity. If I click on the x-intercept, I can see that it is at -1, 0. The y-intercept is going to be at 0, and it's about 0.47. If I can click on it, I can see the decimal value. The minimum will be this starting point right here. So it has a minimum of -4 at x equals -5. So now let's graph a different square root function and describe its key features. So let's type -2, and then we have the square root of x plus 3. And we click outside the square root and then do -1. So now let's start off by creating the table. So I'm just going to do table, and then I'm going to enter these values that it's asking me for. So -3, -2, 1 and 6, and then I'm going to delete this last value. So now I have an idea of some points that are included on the graph of my function. And now let's describe the domain and range. So the domain, you can see the leftmost point is at -3, and then this graph is headed to the right. So it's going to go from -3 to positive infinity. This graph looks a little bit different than the previous ones, and that's because it's headed down. So we would say that this graph, the lowest y value is actually negative infinity because it keeps going down as we continue with our graph. So the lowest value will be negative infinity, and from there it's headed up to this endpoint here, and the y value there is -1. So we would say it goes from negative infinity to -1, and we're going to do the square bracket at -1. Let's click on the intercepts to see what they are. Notice it has no x-intercepts, and that's because the highest y value is -1. It does have a y-intercept, so if I click on it, I can get that value. The y-intercept is going to be 0, -4.46. And it does have a maximum this time, right? It's not a minimum value, it's a maximum because every other y value is going to be lower than -1. So it has a maximum of -1, and that's going to occur at x equals -3. So remember, square root functions have several important characteristics we can identify by graphing the functions in Desmos. These characteristics include the domain and range, intercepts, and maximum and minimum values.